Okay, let's have a look at Pearson's correlation coefficient. Whenever we have X and Y type data and we want to know whether or not there's a relationship between the X and the Y, we try and find this correlation coefficient. Now, the Pearson's correlation coefficient itself tells us whether or not there's a linear relationship between these two variables, and the number can only run between -1 and +1. Closer it gets to -1, the stronger is the relationship in the negative direction, and of course the closer it gets to +1, the stronger is the relationship in the positive direction. If R gets close to 0, it's really telling us that there's not much of a relationship or a correlation, between the two variables. Alright, we have a little set of data here, X and Y data pairs. And in order to find the correlation coefficient, first thing you would do would be to find the average of the x's and the average of the y's, which is what's done right here. And the standard deviations of the x and the y are also found. Once you have the means, you find the deviations in the x direction, which is what's going on right here. So all my x data points, 6, 10, 14, 19, and 21, are all subtracted, or 14 is subtracted from each one of those to get me these deviations, some of which are positive, some are negative. We do the same thing with deviations in the y direction. All the y numbers are subtracted from their mean. Once you get these deviations, you then multiply the deviations together, and that's right here, that's referred to as the cross product between the x and the y. So the -8 times -2 gets me +16, -4 times -4 gets me +16, etc. So we find these deviations, we find the cross product between the two. You sum up all those products. In this case, you get 72. You then divide by n-1, where n is the total number of data pairs. We've got 5, so it'll be 72 divided by 4 is going to give us 18. And then you take that 18 and you have to divide that by the product between the standard deviation in the x times the standard deviation in the y. That gets me to 21.02. So we divide those two numbers and we get a correlation coefficient of 0.856 for these data. Now this number is getting close to a +1, which would suggest that there is a strong positive, perhaps linear relationship between these two variables. I hesitate to say linear because we really should have a picture of these data. In other words, we need a graph, and on a separate video I'm going to do the scatter plot, which also illustrates these data. Alright, so if you worked it out by hand, we see what the calculations look like, and you know, there's 5 data points here, and this is a little bit of work, so you can just imagine what this would be like if you had 50 or 100 data points to work with. So let's go to Minitab and see how we would do it in Minitab. Okay, I've got the data here in columns C1 and C2, and make sure that, you know, each one of these is a data pair, so 6 and 5 and 10 and 13, etc. Okay, we go to the Stat tab, Basic Statistics. 3/4 of the way down, we're looking for correlation, and Minitab tells us that this will be a number that measures the strength and the direction meaning positive or negative, of the linear relationship between the two variables. Alright, you pick your 2 columns of data, and by default it's going to do Pearson's correlation and leave it at that. Click OK, and here's the answer we get. Now notice it doesn't tell me that this thing actually represents R, but that is what it is. It's referred to as Pearson's R. This business with the p-value, we're going to ignore the significance of this for the time being. Alright, in a separate video I'm going to show you the scatter plot for these data.